Hello, welcome to this lecture, chapter 1 of process control. This is an introduction part 2. We have seen in the last part, in my last lecture, we have seen what is process control, why is it required, and what are the requirements of a process control system. Now, having studied those things, now let us see some terminologies associated with process control. Before we go into it, I request you all to subscribe to this channel. If you like it, please share it to your friends and give your comments on this lectures. So please subscribe. Please go to the channel and click the subscribe button. Well, so what are the terms associated with this process control? Simple, there are a few terms which will be occurring throughout this course. So let us see them. First one is controlled variable. So this, as I said, is a continuation of the previous lecture. So if you have not listened or if you have not seen my previous lecture, which is part 1, please go through that. The link for that is given in the description below, or it may appear above this lecture. So the link for the previous lecture will appear above, and you can click on that and go through the basics of process control. What is process control, which was described in the previous lecture. So when in a process control system, the main objective is to maintain some variables at desired value. So which variable you would like to focus upon? Which variable you want to maintain at a desired value, at a desired level? So that variable is known as controlled variable. So control variable is a variable which is to be maintained at a desired level or value. Next, so what is the desired value of this control variable? What value you want for this control variable? That is known as set point. So set point is the desired value of the controlled variable. CV is controlled variable. This is a numerical value. Suppose if it is a flow rate, you may want the flow rate to be fixed at, say, 10 kg per hour. So then set point becomes 10 kg per hour. So let us, okay. So that is set point. The third one is error. So the error is the difference between set point and the value of the controlled variable. The difference, set point minus the value of the controlled variable, is called error. So let us see some examples. So this is an example of a process wherein a liquid is continuously heated from one particular temperature to another particular temperature. So the aim is to heat a liquid of known flow rate m kg per hour from temperature Ti to T. So what do you require for this? So we can design this for this requirement, for this process requirement. If you are going to use steam as a heating medium, you can calculate and design how much steam is required at a given pressure and temperature. So how much steam, ms kg per hour, how much is required at a given temperature and pressure, and what is the size or area or size of the heating vessel. So this can be designed. So having designed this, then the process requirement will be met. That is, you can heat mkg per hour of Ti of liquid from temperature Ti to outlet temperature T using this steam of these quantities. So if your focus, if your requirement is the liquid outlet temperature is to be maintained at a constant level T, I always want to maintain. That is the requirement given in the statement. That is a liquid to be heated from this temperature to this temperature. So if you want to maintain this outlet temperature at a constant value, then we can choose or we can choose the liquid outlet temperature as the control variable. So in this case, for this control objective, the controlled variable is the liquid outlet temperature. So the control variable is the liquid outlet temperature T. So if there are some disturbances, I want the control system to restore this temperature, liquid outlet temperature T. There may be some external different disturbances which might cause this liquid outlet temperature to vary, and I want the control system to restore that temperature to T. So the control variable is chosen as liquid outlet temperature. Right. So next one is set point. So set point is a numerical value. For example, I want the liquid outlet temperature to be at 70 degrees centigrade. So I want the liquid outlet temperature is 70 degrees centigrade. That is 70 degrees centigrade is specified as a desired temperature of the liquid outlet, the outcoming liquid. So then we call a set point is 70 degrees centigrade. So set point is a numerical value. It's a desired value of the control variable. Then error. Suppose you want the set point is 70 degrees. At a particular time, you measure this temperature here and say it is 75. So instead of you what is 70, when you measure it becomes it is found that liquid out temperature is 75. Then the error is if the temperature is if you take the temperature as 65 and you measure, suppose you measure the temperature at any time, you find it is 65 degrees centigrade, 65. Okay, you find it as 65. You find the temperature as 65 instead of the desired value 70 degrees. So the error is set point 70 minus the value of the control variable 65, 5 degrees centigrade error. The set point required value is 70, but when you measure, because of something has happened, though, so temperature is not 70, it is only 65. It is only 65, though, so there's an error of 5 degrees centigrade. Suppose when you measure at some other time, the temperature is 72. If you measure some other time, the temperature is 72, then the error is 70 minus 72. 70 minus 72, so it becomes minus 2 degrees centigrade. So error can be positive, error can be negative, depending on whether the value of the control variable is above the set point or below the set point. Okay. So that is about control variable. What is control variable, set point, and what is error? So next term is load variable or disturbance variable. So a variable which causes change in the control variable is known as a load variable. So any variable which can cause a change in the control variable is known as load variable, because our aim is the control variable that has to be maintained at a set point. So if some other variable can cause a change in this control variable, can cause a change in the value of the control variable, it's known as load variable, disturbance variable, or simply load. Then when there is a change, so the load variable can cause a change in the control variable. The external disturbances in the load variables can affect the value of the control variable. So there can be an error. So control system should compensate this error and restore the value of the control variable to the set point. How it will be done? So it will be done by usually adjusting another load variable. So that particular load variable which is adjusted to offset the error, another load variable which is adjusted or manipulated to offset the error is known as manipulated variable. Hope it is understood. So load variable and manipulated variable. So manipulated variable is also one of the load variables. When there is a change which is going to cause a change in the control variable, when there is an external disturbance which is going to affect the control variable, what can be done to offset the error? Another load variable has to be adjusted. So that particular load variable which is adjusted is known as manipulated variable. So in this case, come back to this example, stir tank heater. The control variable is the liquid outlet temperature. So this is the control variable. So what can cause, which variables can cause affect this variable? This liquid inlet flow rate. Suppose the liquid inlet flow rate is different from the designed value. I have designed this process for some particular value of m. If there is a difference in this flow rate, that can change this control variable, is it not? If this liquid inlet flow rate suddenly increases, then the liquid outlet temperature will get affected. It may become less. So this liquid inlet flow rate m is a load variable. Similarly, liquid inlet temperature, that is also a load variable, because if inlet temperature, you might have designed this process to heat this from Ti to T. Let's say Ti is 30 degrees. I have designed this process to heat this liquid from 30 degrees centigrade to set point of 70 degrees centigrade. If the inlet temperature changes from 30, say to becomes from 30, it becomes 25, then there will be change in the control variable. The control variable value will get changed, will get affected. So the liquid inlet temperature also is a load variable. So there may be multiple number of load variables. This is a simple example. The simple example I have taken to illustrate this terminology. So the load variables are the mass flow rate of the liquid, the inlet temperature of the liquid. Similarly, come here to the steam flow rate. The steam flow rate is also a load variable, because if the steam flow rate changes, again there will be change in this liquid temperature. So the steam flow rate Ms, the steam temperature Ts, the steam temperature Ps are also load variables. All of them can cause a change in the liquid outlet temperature, which is the control variable. So there will be multiple number of load variables, not necessarily just one, not necessarily just one or two. Further, if the tank is open to atmosphere, then the atmospheric condition also become a load variable, the atmospheric temperature. So that also becomes a load variable. So there can be any number of load variables. So all these load variables have to be identified. And one of the load variables is chosen as a manipulated variable to offset the error. Suppose if the temperature Ti okay, the outlet control temperature set point is 70 degrees, as I said, but the measured value of the control variable at any time is 65, so there's an error of 5 degrees centigrade. So what I have to do, this liquid outlet temperature has to be brought back from 65 to 70. How do you do that? How do you do that? The easiest way is increase the steam flow rate. Increase the steam flow rate. If you find the liquid outlet temperature is less than the set point, or if there is a positive error, so in this case, what can be done? Simple, increase the steam flow rate. So do it manually, manual control. Do it with automatic instruments and equipment automatically. Everything is done automatically. That is process control, automatic process control, which we are going to see in the rest of the course. So steam flow rate is a manipulated variable. Similarly, this temperature goes to 72. There's an error of -2 degrees centigrade. It has gone beyond the set point, so the steam flow rate has to be reduced. Of course, you can change the TS and PS also, but the easiest thing is vary the flow rate. In most of the situation, the manipulated variable will be flow rate because flow rate is easy to adjust, easy to regulate, easy to vary. So in this case, the manipulated variable is the steam flow rate, right? So we have understood, we have discussed what is control variable, what is set point, control variable, what is set point, what is error, what is meant by load variables, and what is a manipulated variable. So I hope you had understood all these variables, all this terminology. If you have any doubt, you can let me know in the comment section. So as I told earlier, I would request you once again to kindly subscribe to this channel. There's a channel button coming up. Please subscribe to this channel, and the video link for the previous lecture part 1 is given below in the description. You can go through that also. So see you with more lectures on process control. Process control requires majorly Laplace transform. So Laplace transform is a major part of process control. So process control to a large extent requires Laplace transform. So there is a series of my lectures on Laplace transform already in this channel, which are required for our study for this course. You can go through them also. We'll come up. We'll stay tuned for more lectures on this topic, process control. See you.